joint characteristic function. The joint characteristic function is given by the expected value of e power j omega x, e power j omega 2y. Okay. So how do we represent joint characteristic function? Phi xy of omega 1 comma omega 2. This is the formula notation we use to represent the joint characteristic function. Okay. So here what is the formula for joint characteristic function? Phi xy of omega 1 omega 2 is equal to integral minus infinity to plus infinity, integral minus infinity to plus infinity. What is the function here? E power j omega 1x plus j omega 2y f x y x comma y dxy. Okay. So if you observe this formula, what is this formula? This is the formula for two-dimensional Fourier transform. Instead of plus here we should have minus. Okay. So this is the formula for two-dimensional Fourier transform with the signs of omega 1 and omega 2 will be reversed. Okay. Then what is that here we do? We use inverse Fourier transform to find out what is the probability density function, that is fxy of x comma y. So fxy of x comma y is given as integral minus infinity to plus infinity, integral minus infinity to plus infinity, phi xy of omega 1 omega 2 e power minus j omega 1x plus j omega 2y d omega 1 d omega 2. Okay. So like this, using this inverse Fourier transform, we'll be finding joint density function. So from this relation we know that the joint density function and the characteristic function forms Fourier transform pairs. Okay. And what is that here? If x and y are two discrete random variables, in the case of discrete random variables, what is that? The characteristic equation is given as phi xy of omega 1 omega 2 is equal to summation with respect to m, summation with respect to n, e power j omega 1 x1 plus j omega 2 yn phi xm 1 comma yn. Okay. And what is that? Phi p of x1 comma yn is called probability density function. So it is equal to summation with respect to m, summation with respect to n. Here it is e power minus j omega 1 xm minus j omega 2 ym phi xy of omega 1 omega 2. Okay. So these are the two equations we use to obtain. This is the first equation to obtain the characteristic function for discrete case, and this is the equation we use to obtain probability mass function. Okay. And what are the important properties of joint characteristic equation? We know that marginal characteristic function can be obtained from joint characteristic function. What is marginal? Marginal means it is function of only one random variable and one frequency variable. Okay. So it is phi x of omega 1 is equal to phi xy of omega 1 comma 0. So what is omega 2 is the frequency for y. So that will be 0. Similarly, phi y of omega 2 is equal to phi xy of 0 comma omega 2. Okay, here the frequency corresponds to x will be 0. Now both frequency components are 0. Then phi xy of 0, 0 is equal to 1. This is our first joint property of first joint characteristic function. Okay. Then the second property is given as if x and y are independent. Okay. In that case, the joint characteristic function is equal to product of their individual characteristic functions. That is phi xy of omega 1 comma omega 2 is equal to phi x of omega 1 phi y of omega 2. Okay. So that is the case for if two random variables are independent. Okay. So if x and y are two independent random variables, in that case, if phi x plus y, here you see that it is function of one frequency component, whereas in the previous property you can see that here we have two frequency variables, omega 1 omega 2. So whereas in the property 3 we have only one frequency variable. So if we have phi of x plus y of omega is equal to phi x of omega phi y of omega. Okay, that is our third property of joint characteristic function. And this is very important property. This will give you the joint moments from the joint characteristic function. So what is the relation between joint moment and joint characteristic function is given by mnk is equal to minus j power n plus k dou of n plus k phi xy of omega 1 comma omega 2 by dou omega 1 power n dou omega 2 power k, where omega 1 is equal to 0 and omega 2 is equal to 0. This is very important property of joint characteristic function. Okay. Now, so now we see here what is the problem. The problem is given like this. The joint density function of two random variables x and y is given as f x y of x comma y u of x u of y 4 e power minus 2 x plus y. Okay. Now we have to find the mean value of the function e power minus x plus y. Okay. Now what is the formula for finding the mean value? It is expected value of e power minus x plus y. So in the formula here we should have the function, whatever function is given, that function should be placed here, and its probability density function we have to consider. Okay. So it is integral minus infinity to plus infinity, integral minus infinity to plus infinity, the function and the joint probability density function dx dy. Okay. And what is the function here? E power minus x plus y. And you just observe the joint probability density function. We have u of x and u of y. U of x means that x range is only from 0 to infinity, y range is also from 0 to infinity. Okay. So that is why we will be having the range as 0 to infinity and 0 to infinity, and substitute fx of fxy of x comma y also. Then you do this integration and you find out what is the expected value, mean value of a given function.